Hello, we are Team 9. This week, in preparation for the final presentation, we will provide additional information on the load transfer of the hanging cantilever, as discussed last time, and supplement the previous presentation on excavation and foundation. Given that the ground beneath the CCTV headquarters building was not stable and the area is prone to frequent earthquake, the foundation was of paramount importance. Consequently, a piled raft foundation was chosen, followed by the bottom-up construction method, starting from the underground structures and progressing upwards. The process began with a soil investigation to evaluate the ground conditions and determine the optimal locations and depth for the piles. Once this assessment was complete, excavation commenced to reach the necessary depth for a stable foundation. During excavation, diaphragm walls were installed to prevent soil collapse and ensure stability. Upon completion of the excavation, piles with a diameter of 1.2 meters and a length of 52 meters were driven into the ground. These piles serve to transport the building's load to deeper, more stable soil layers. Following the pile installation, the left foundation was constructed atop the piles. The left foundation works in conjunction with the piles to evenly distribute the entire building loads, mitigating the risk of punching shear failure, which could occur if only piles were used due to their small cross-section area. After installing the piles, rebar was placed in the left foundation and concrete was poured. HRB 50 grade rebar was used for the left, with the lower section reinforced with 2 to 7 layers of mesh and the upper section with 2 to 3 layers of mesh. The concrete pouring for Tower 1 took 52 hours with a total volume of 39,000 cubic meters. For Tower 2, the concrete pouring took 54 hours with a total volume of 33,000 cubic meters. The total volume of concrete poured for the base plate exceeds 120,000 cubic meters. During the massive concrete pouring process, crack control is the critical aspect. To address this, CCTV implemented two key methods. The first method involved increasing the proportion of fly ash in the concrete mix to 49%. Fly ash enhances the workability of concrete, reduces shrinkage, prevents shrinkage cracks, and lowers the heat of hydration, thus preventing temperature-induced cracking. The second method included using a combination of plastic sheets, 3 layers of straw mats, and 1 layer of canvas for insulation and maintenance. Additionally, a large capacity concrete computer temperature monitoring system was employed to measure the temperature in real time. Maintaining appropriate temperature and humidity levels while the concrete gains initial strength is crucial for preventing cracks, and this method effectively ensures this. The core of the building creates moments due to lateral loads and horizontal displacement. Even in the tower side core fixed to the ground, these lateral loads act fatal. Especially in CCTV buildings, there was a core without footings in the cantilever part, which required further consideration. So, what method could have been used to solve this problem? The answer was to install the transport truss, which acts as an outrigger. The outrigger system connects the core to a mega column or wall, reducing the moment of the core and holding the displacement. The CCTV building was able to effectively control the load by connecting the core and the tower side in the form of the truss by pin contact and transferring the retro load on the hanging cantilever core to the solid tower part.